Previous video classes ಅಲ್ಲಿ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್ ಅಂದ್ರೆ ಏನು, ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್ ಟೈಪ್ಸ್ ಎಷ್ಟಿದೆ, ಸೊ ಆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್ ಇಂದ ಏನೇನೆಲ್ಲ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಇದೆ, ಆಲ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಲರ್ನ್ಡ್ in the previous video classes. There are 4 types of quantum numbers, which are those: principal quantum number, azimuthal quantum number, then magnetic quantum number and spin quantum number. So principal quantum number in the electron ಯಾವ main shell ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Next azimuthal quantum number ಇಂದ ಯಾವ subshell ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Next magnetic quantum number ಆದ್ಮೇಲೆ the magnetic quantum number ಅಲ್ಲಿ so ಯಾವ particular orbital ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Subshell ಅಲ್ಲಿ ಯಾವ orbital ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Then spin quantum number ಬಂದಾಗ so we can just consider whether it is rotating in clockwise direction or anti-clockwise direction. Then based on the principal quantum numbers, even we can compare the energies with different orbitals. So ನೀವು ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಏನು ಡಿಫ್ರೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಇರುತ್ತೆ, ಆ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ನ ನಾವು ಕಲಿಬೇಕಂದ್ರೆ we have to take the help of quantum numbers. Now once we have learned these, now this is the topic regarding the shapes of the orbitals. First, importantly, you should remember orbit is different from orbital. Orbit ಅನ್ನೋದೇ ಬೇರೆ, orbital ಅನ್ನೋದೇ ಬೇರೆ. Orbit ಅಂದ್ರೆ shell ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು, energy, main energy level. So here we are going to consider the topic name is shapes of orbitals. Very first, do you remember what is meant by orbital? Orbit ಅಂದ್ರೆ ಬೇರೆ, orbital ಅಂದ್ರೆ ಬೇರೆ. ಹಾಗಾದ್ರೆ orbital ಅಂದ್ರೆ ಏನು ಹಾಗಾದ್ರೆ? Orbital, it is the 3-dimensional space around the nucleus where the probability of finding electron is maximum. ಅಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಪೇಸ್ ಅಂದ್ರೆ 3-dimensional ಸ್ಪೇಸ್ ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಎಲ್ಲಿ ಒಂದು ಸಿಂಗಲ್ ಆಟಮ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆಟಮ್ ಸೆಂಟರ್ ಪಾರ್ಟ್ ಇರುತ್ತೆ, ಅದನ್ನ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ಕರಿತೀವಿ. ಆ ನ್ಯೂಕ್ಲಿಯಸ್ ಸರೌಂಡ್ ಆಗಿ ಏನ್ ಸ್ಪೇಸ್ ಇರುತ್ತೆ, ದಟ್ ಈಸ್ ಇನ್ ಆರ್ಬಿಟ್ಸ್, there will be 3-dimensional region where the probability of finding electron is maximum. ಇಲ್ಲಿ ನಾವು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಇದ್ದೇ ಇದೆ ಅಂತ ಹೇಳ್ತಿಲ್ಲ, most probably the maximum probability of finding electron, that will be probability will be very much high to find the electron density. Now based on that electron density, we can just consider there are different types of orbitals. As we can consider 4 important orbitals we are going to learn today, that is s orbital, p orbital, d orbital and then f orbital. So now we can say, very importantly, as per your syllabus is concerned, so we have to importantly remember what are the shapes of the orbitals with respect to S, P and D. Of course, F, it is not given in your syllabus, it will be having complicated structure, but anyway we are going to learn about the shape of S orbitals, P orbitals and D orbitals one by one. Which is that very first orbital? That is very first orbital is S orbital. Now we can consider S, P, D, F. ಈಗ ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದೆ. ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಗೆ ಸಿಂಬಲ್ ಏನು? ಎನ್. ಸೊ ಅಜಿಮುಥಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಗೆ ಸಿಂಬಲ್ ಏನು? ಎಲ್. ಸೊ ನಾವು ಇಂಪಾರ್ಟೆಂಟ್ಲಿ ಇಫ್ ಯು ಕಮ್ ಫಾರ್ ದೀಸ್ ಎಸ್ ಪಿ ಡಿ ಎಫ್ ಆರ್ಬಿಟಲ್ಸ್, ಸೊ ದೇ ಆರ್ accommodated in different subshells like S subshell, P subshell, D subshell and F subshell. Now of course we can consider S corresponds to that L value, azimuthal quantum number value for S orbital will be exactly equal to 0. As I told you repeatedly, L value starts from not 1, it begins with 0. For S orbital, L value is 0. For P orbital, L value is equal to 1. For D orbital, L value is equal to 2. Then for F orbital, that L value will be equal to 3. Got it? And now of course, if you consider this S subshell contains only one orbital, because what is that? After principal quantum number n, you will come for azimuthal quantum number. After azimuthal quantum number, you will get that magnetic quantum number. So in this magnetic quantum number, if L is equal to 0, M is equal to 0. Therefore, only one orbital is possible for S subshell, that is S orbital itself. Of course, for P subshell, L is equal to 1, but magnetic quantum number that starts from minus L to plus L, that is minus 1 to plus 1, 3 possible values, minus 1, then 0, plus 1. Therefore, minus 1 corresponds to, that is Px, we can just consider Px, Py, Pz. Therefore, P subshell is divided into how many orbitals? 3 orbitals, namely Px, Py and Pz. Then, of course, if we come for d orbital, even you should remember the types of d orbital. So, here the dl value corresponds to 2. Then, m is equal to minus L to plus L. That is minus 2 to plus 2. Minus 2, minus 1, 0, plus 1, plus 2. Then obviously we can write how many types of orbitals are there for d subshell? 5 types of orbitals. Which are those? We can mention them, very easy to remember. dxy, dyz, dzx, dx square minus y square, and one more dz square. Totally how many orbitals are possible? 5 types of orbitals are there in d subshell. And of course, you remember, no need to remember those types of the f orbital because of it, if it's complicated structure. You just remember the possible number of magnetic quantum numbers for f will be minus L to plus L, means then m is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So obviously, we can just remember how many types of orbitals are there with respect to f subshell. There are totally 7 orbitals. Hence, now we are going to learn how we are going to get these 3 types. How we are going to get these 5 types. It is based on the arrangement of the electron cloud density. The shape of the electron cloud density will give us these different names here. Now, very first we can start with, which is that first type of the orbital, s orbital. In case in examination, if they ask for one more question, what is the shape of s orbital? Then obviously we can give very simple answer, which is that answer, spherical shape. So, what is the shape of the s orbital? Shape of the s orbital is spherical. So, it is having spherical shape. Then we can just mention, if it is 1s orbital, I can just mention it as the electron cloud density. What is that shape of that electron cloud density? It has got spherical shape, isn't it? Now we can just say, we are mentioning the 3 axes here. Here 3-dimensional space anta helidini. Orbitals are 3-dimensional space around the nucleus. So now if we consider 3 axes, x-axis, y-axis, and there will be z-axis. Now we can say that if the 3 axes are there, so one will be, now let us consider 3 axes. One axis will be perpendicular to the another axis. So it is x-axis, it is y-axis, and it is z-axis. So x is perpendicular to y, y is perpendicular to z, and z is perpendicular to x. That means 3 axes are perpendicular to each other. The angle between any 2 axes will be exactly equal to 90 degree. Hence we can say that, so that x, y, z, ಈಗ 3 axes ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀನಿ. x axis, y axis ಮತ್ತು z axis. ಈಗ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಡೆನ್ಸಿಟಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ it is uniformly distributed throughout this x axis, y axis and z axis. Therefore, here we can say that the shape of that s orbital will be only spherical. It has got only one type. Hence, that s subshell has got only one orbital, that is s orbital itself. Now, if we come for p subshell. P subshell is of 3 types of orbitals. It is made up of 3 orbitals. Which are those 3 orbitals? px, py and pz. ಯಾಕೆ ಇಲ್ಲಿ suffix x ಇಲ್ಲಿ y ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಿ, z ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಿ? It is based on the distribution of the electron cloud density around the 3 axes. Now we can say, even 3 axes, very easy to. It is important even to remember the representation of the different p orbitals. I can raise the question in examination. Just represent the shapes of the p orbital. Draw the shapes of the 3 p orbitals they can ask. Then we can easily remember these diagrams too. Easy to write. How to write these diagrams? So just remember 3 axes. First you draw 3 lines. X axis, then y axis, then other one is z axis. Once you write these 3 axes, then specifically I have mentioned px. Why I have mentioned here px orbital? Here because that very importantly you remember the shape of the, what is the shape of the p orbital? For 1 mark question if they ask, the answer will be dumbbell shape. Dumbbell shape. What is the shape of p orbital? Dumbbell shape. The dumbbell shape actually consisting of 2 lobes here. The 2 lobes. It is made up of 2 lobes. Then pair of lobes. So left and right here. Now you can consider that the electron lobes will be representing the shape of the electron cloud density. That electron cloud density, it has got lobe shape. That is actually mentioned with the specific name dumbbell shape. Hence, this dumbbell shaped lobes are orienting actually along which axis here? X axis. ಹಾಗಾದ್ರೆ x axis 3 axis ಅಲ್ಲಿ ಆ ಲೋಬ್ x axis ಕಡೆ ಓರಿಯೆಂಟ್ ಆಗಿದ್ರೆ ಅದನ್ನ ನಾವು ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ px orbital ಅಂತ ಕರೀತೀವಿ. Then next second type of orbital for p subshell is py orbital. You just mention the same. ಮತ್ತೆ 3 lines ನ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳಿ perpendicular to one another, that is x axis, y axis and z axis. And of course, here in spite of writing the lobes along x axis, here I have drawn along the y axis. Hence, I have mentioned the name for this orbital as py orbital. What is the shape of this orbital? It is also, that is same, dumbbell shape. In general, if they ask the shape of, what is the shape of p orbital, you can mention it as dumbbell shape. Then, after py orbital, then one more type of p orbital is pz orbital. So, along these 3 axes, x axis, y axis and z axis, here that pair of lobes is orienting along which axis? Z axis. Hence, it is represented as pz orbital. Now, I think you can easily remember what are the 3 types of orbitals for p subshell? Px, py and pz. So, that p subshell is made up of 3 orbitals, px, py and pz. So, of course, here we can consider they are said to be degenerate orbitals. Andre, ಈ px, py ಮತ್ತು pz orbitals ಗೆ equal energy ಇರುತ್ತೆ. They have got equal energy. Hence, it has got capacity to be filled with the electrons. Maximum ಎಷ್ಟು electrons fill ಆಗುತ್ತೆ? 1, 2. Each orbital can accommodate 2 electrons. Hence, total number of electrons can be present in any p subshell will be equal to 6 electrons. Hence, maximum of how many electrons can be filled in any p orbit, that is p subshell, that is 6, p6. Now, once you remember that what is the shape of s orbital? It is spherical shape. What is the shape of p orbital? It is dumbbell shape. What are the 3 types of p subshell? There are 3 types of p orbitals, means that is p, x, py, pz. Why p subshell is divided into 3 types of orbitals? Then you should know the reason for this question. Because they will differ in their orientation along the x axis, y axis and z axis. Hence, p subshell is divided into 3 types of orbitals. If there is a question, next one, that is regarding d orbitals also. Why d subshell is divided into 5 types of orbitals? For that question also the same answer, that is depending on the difference in the orientation of the orbitals along 3 different axes, the d subshell can also be divided into 5 types of orbitals. Now, this is regarding s orbitals and p orbitals. Then we can go for the different types of d orbitals. If we consider d subshell, so d subshell will be of 5 types. So that d subshell is made up of 5 types of orbitals. So namely dxy, dyz, dzx, dx square minus y square and dz square. Remember x, y, z. Pair up with the xy, then yz, then zx. Then remaining two, x square minus y square and z square. You should remember these terms, that is xy, yz, zx, x square minus y square and z square. So 5 types of combinations you should remember. And now very first, so here why we have just made it to 5 types. So we are considering only 5 types of orbitals will be present in the subshell. So it is depending on the orientation along the 3 axes, x-axis, y-axis and z-axis. Now if you start with, I have specifically mentioned that first representation for d orbital, that is dxy orbital. As you consider the same axis, x-axis, y-axis and z-axis. ಈಗ 3 axis ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಇದು x ಇದೆ, ಇಲ್ಲಿ y ಇದೆ, ಇನ್ನೊಂದು ಯಾವ ಆಕ್ಸಿಸ್ ಇರುತ್ತೆ, ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ z ಆಕ್ಸಿಸ್ ಇರುತ್ತೆ ಆಫ್ ಕೋರ್ಸ್. ಬಟ್ ಆ 3 ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ here we can just mention the same dumbbell shape, but p orbital only one pair of lobe ittu. So here there are 4 lobes here, 2 pairs of lobes here. So here we can mention the shape of d orbital as double dumbbell shape. Double dumbbell shape. That is the shape of, what is the shape of d orbital? The answer will be double dumbbell shape. Here we can just remember 4 lobes I have written here. These 4 lobes are actually orienting along x and y axis plane. ಈಗ 3 axis ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ x axis, y axis and there will be z axis we can remember. So ಈಗ xy plane ಏನು ಬರುತ್ತೆ, the xy plane ಅಲ್ಲಿ lobes 4 lobes arrange ಆಗಿರುತ್ತೆ. So hence we can just remember, ಈಗ ಬೋರ್ಡ್ ಮೇಲೆ ಏನು ಬರ್ದಿದ್ದೀನಿ, x ಮತ್ತೆ y ಎರಡು ಆಕ್ಸಸ್ ಅಲಾಂಗ್ ದ ಪ್ಲೇನ್ ಆಫ್ ದ ಬೋರ್ಡ್ ಇದೆ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಈಗ 4 lobes ಕೂಡ ಏನಾಗುತ್ತೆ, ದೇ ಆರ್ ಲೈಯಿಂಗ್ ಅಲಾಂಗ್ ದ plane of the board. That means dxy representing the 4 lobes, they are lying along the plane of the xy axis. Hence they are mentioned it as dxy orbital. Then similarly, if you consider next dyz, you write the same, draw 2 lines here. You mention one as y axis, another one as z axis. You don't get confused here. Always you should write x here and y here. ಯಾಕೆಂದ್ರೆ 3 ಆಕ್ಸಿಸ್ ಅಂತ ಏನು ಬರ್ತೀವಿ, 3 ಡೈಮೆನ್ಷನಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆಕ್ಸಿಸ್ ಯಾವಾಗಲೂ x ಆಕ್ಸಿಸ್ ಹೀಗೆ ಬರಬೇಕಂತ ಏನಿಲ್ಲ. ಸೊ ಇಫ್ ಯು ರೊಟೇಟ್ ದಟ್ ಫಿಂಗರ್, ಸೊ x ಆಕ್ಸಿಸ್ ವಿಲ್ ಕಮ್ ಡೌನ್. ಸಿಮಿಲರ್ಲಿ if you consider after rotation with different angles, we can even change the letters. As here I have mentioned it as y axis, it is z axis. Specifically you remember dyz orbital means one side you represent y, another side you represent z. Otherwise you can mention here it as z or it is y. Both are correct. Now dyz orbital anta consider ಮಾಡಿದಾಗ one axis ಗೆ y ಅಂತ ಕೊಡಿ, ಇನ್ನೊಂದು axis ಗೆ z ಅಂತ ಕೊಡಿ. Now the 4 lobes are lying along the axis of the yz. Hence the name of that orbital will be dyz. The next one, the 4 lobes are lying along the zx orbital. In case if we consider the 4 lobes are lying along the zx plane, then it is represented as dzx orbital. Here also 4 lobes will be present. Then if you consider dx square minus y square, here as I have mentioned here, it is x axis, it is along y axis. Now one pair of lobes will be exactly along the x axis, another pair of lobes will be exactly along y axis. Hence they are mentioned with that different combination, that is dx square minus y square. Then last one more possibility for the orientation is, here we can just say it is dz square. Here that one pair of lobe will be exactly along the z axis and another will be having almost donut. Hence that shape of this dz square orbital is particularly mentioned as donut shape. Donut shape. And In general, if they ask for what is the shape of D subshell, we can just mention it as double dumbbell shape. So there is these are the representations with respect to 5 different orbitals of D subshell. Here I can just say D subshell, it is having the L value is equal to, here we can start with 0, 1, 2, 3, 0 with respect to S, P, T. Then L is equal to 2 for D, that is the D subshell, L value is equal to 2. Hence we can write with the number -2, -1, 0, then +1, +2. Totally how many possibilities are there? 1, 2, 3, 4, 5 possibilities. Hence these are representing the correct numbers with respect to D orbitals. And what is the maximum number of electrons can be accommodated in D subshell? Totally there are how many orbitals are there? 5 orbitals. Hence we can accommodate maximum of how many electrons? 10 electrons. Therefore maximum number of electrons can be accommodated in D subshell is 10. But of course, in each and every orbital, that is either it is dx square, y square, or dz square, or dzx. So each orbital can accommodate maximum of only 2 electrons. And of course, here we can say these D orbitals are said to be degenerate. Like px, py, pz orbitals are having same energy, identical energy. Hence, they are said to be degenerate. Here also, because of their orientation and they will be having similar energy, hence they are said to be degenerate. These different 5 orbitals of D subshell are also said to be degenerate orbitals. Degenerate means having equal amount of energy. So that is regarding shape of the orbitals, S orbital, P orbital and D orbital. Of course, if you go for F orbital, it will be having complex structure. You need not worry about the types of these F orbitals. Only thing you can remember is for F, if you come for F subshell, maximum how many electrons it can accommodate? We can remember it can accommodate of maximum 14 electrons because it will be of 7 types of orbitals. Each orbital is, if it accommodate 2 electrons, then total number of electrons which can be present in F subshell will be 40. Now we have come to last topic in this chapter, that is regarding filling of electrons in different orbitals. Here we can consider if any atom is said to be having a particular atomic number, then depending on that atomic number we are going to fill those number of electrons in different orbitals. Of course, we can't fill up these electrons haphazardly in whatever way we want. But there are certain rules to be followed. Before filling the orbitals, we need to learn those rules to be followed. First, you should know what is meant by electronic configuration. So, ಯಾವುದನ್ನ electronic configuration ಅಂತ ಕರಿತೀವಿ. Usually, ಒಂದು atom ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆಟಮ್ ಅಲ್ಲಿ ಅಟಾಮಿಕ್ ನಂಬರ್ ಅಂತ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಅಟಾಮಿಕ್ ನಂಬರ್ ಆಫ್ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ಆ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ನಾವು ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ ಫಿಲ್ ಮಾಡ್ತೀವಿ. ಸೊ ಆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್. ದಟ್ ಮೀನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ which is nothing but it is the distribution of electrons into different orbitals of an atom. So of course we can consider, ಈಗ ಆಟಮ್ ಅಂತ ಹೇಳಿದಾಗ ಐಸೋಲೇಟೆಡ್ ಆಟಮ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಯೂಶಲಿ ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಇದ್ದಾಗ ನಾರ್ಮಲ್ ಆಗಿ ಆರ್ಬಿಟಲ್ಸ್ ಅಂತ ಏನಿರುತ್ತೆ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಐಸೋಲೇಟೆಡ್ ಆಟಮ್ ಅಲ್ಲಿ, ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ಎನರ್ಜಿ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿಲ್ಲ. ಸೊ ಯಾವ ಎನರ್ಜಿ ನಾವು ಅಲ್ಲಿ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇಲ್ಲ ಒಂದು ಆಟಮ್ಗೆ. ಸೊ ಆಟಮ್ ಸ್ಟೆಬಿಲೈಸ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇದೆ, ಐಸೋಲೇಟೆಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇದೆ, ಅದನ್ನ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಆ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ದೇರ್ ವಿಲ್ ಬಿ ಸರ್ಟೇನ್ difference in the energies of different orbitals. Here we can say which are those rules to be followed to fill the orbitals. Then we have to learn those rules one after the another. So our very first rule yavadna kaltkolta idivi. So very first rule that to be followed for filling atomic orbitals, that is we can start with, it is nothing but the half-bow principle. So half-bow principle. So half-bow principle ಏನು ಹೇಳುತ್ತೆ? So according to half-bow principle, in the ground state of an atom, the electrons are filled in different orbitals in the increasing order of their energy. It's very simple. So Hubble principle ಪ್ರಕಾರ ಒಂದು ಆಟಮ್ ಅಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಂತ ಏನಿರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗಬೇಕಾದ್ರೆ ಲೋವರ್ ಎನರ್ಜಿಯಿಂದ ಹೈಯರ್ ಎನರ್ಜಿ ಆರ್ಬಿಟಲ್ಸ್ಗೆ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಯಾವ ಆರ್ಬಿಟಲ್ಗೆ ಫಸ್ಟ್ ಎನರ್ಜಿ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಫಸ್ಟ್ ಫಿಲ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಅದಕ್ಕಿಂತ ನೆಕ್ಸ್ಟ್ ಒಂದು ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಯಾವ್ದು ಜಾಸ್ತಿ ಇರುತ್ತೆ ಆ ಆರ್ಬಿಟಲ್ಗೆ ಫಿಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ according to Hubble principle, the ground state of the atom, the electrons are filled in different orbitals in the increasing order of the energy. Now I am representing it with respect to these different orbitals. Very first we can start with 1s. ಈಗ ಫಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಒಂದೇ ಒಂದು ಸಬ್ ಶೆಲ್ ಇದೆ, ಯಾವುದು ಎಸ್. ಇಲ್ಲಿ ಆ ಮೇನ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ನ 1 ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ, 1s ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಶೆಲ್ ಅಲ್ಲಿ 2 ಸಬ್ ಶೆಲ್ಸ್ ಇರುತ್ತೆ, 2s ಮತ್ತೆ 2p. ದೆನ್ ಇನ್ ದ ಥರ್ಡ್ ಮೇನ್ ಶೆಲ್ 3 ಸಬ್ ಶೆಲ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್, 3s, 3p, 3d. ಸೊ ನಾವು ಕಲ್ತಿರೋದು ಟೋಟಲ್ ಯಾವ್ಯಾವ ಆರ್ಬಿಟಲ್ಸ್ ಇದೆ, ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಂದ್ರೆ ಎಸ್, ಪಿ, ಡಿ ಸಬ್ ಶೆಲ್ಸ್ ಅಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಇದೆ. ಈಗ ನಾವು ಇದನ್ನ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಎಸ್, ಪಿ, ಡಿ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. We are not expanding those orbitals like px, py, pz, or dx square minus y square or dz square. Just subshells na represent ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So 1s ಆದ್ಮೇಲೆ 2s, 2p. Then I have written 3s, 3p, 3d. Then 4s, 4p, 4d, 4f. Then similarly we can write how many lines you want, you can write yourself. So I have stopped over here, that is up to 6. Shell number 6. 3spd. Here 4spdf, 5spdf, 6spdf. Now, very first we can start with which is having very least energy. That orbital which is very much closer to the nucleus. Of course, 1s orbital will be very smaller in size and even it is very nearer to the nucleus. Here, 1s is having least energy. Then after that, you will come for 2s. Then here we can say after 2s that electron, if 1s orbital is completely filled, then next electron will go to the 2s orbital. ಈಗ 1s ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗುತ್ತೆ, 2, 1s 2 ವರೆಗೂ ಫಿಲ್ ಮಾಡಬಹುದು. ಅದಾದ್ಮೇಲೆ 2s ಗೆ ಬನ್ನಿ, 2s ಅಲ್ಲಿ ಥರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಫಿಲ್ ಮಾಡ್ತೀರಾ, ನೆಕ್ಸ್ಟ್ ಫೋರ್ತ್ ಎಲೆಕ್ಟ್ರಾನ್, ಮ್ಯಾಕ್ಸಿಮಮ್ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಫಿಲ್. 2s ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿಗೆ ಫಿಲ್ ಆಗುತ್ತೆ, 2p ಗೆ. ಸೊ ಎಲ್ಲಿವರೆಗೂ ಫಿಲ್ ಆಗುತ್ತೆ, ಅಪ್ ಟು ಇಟ್ ವಿಲ್ ಬಿ ಫಿಲ್ಡ್ ವಿತ್ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. 2p 6 ಆಗೋವರೆಗೂ ಇರುತ್ತೆ. ಅದಾದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಇಟ್ ವಿಲ್ ಗೋ ಟು ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಬಿ ಆಡಿಂಗ್ ಟು 3s. After 3s you will go for 3p. Then after 3p, then it is not added to 3d, but according to this arrow mark it is shown that after 3p that added electron will not enter to 3d but instead it is entering to 4s. ಯಾಕೆ ಅಂದ್ರೆ ಈಗ 3p ಆದ್ಮೇಲೆ ಈ 4s ಮತ್ತೆ 3d ಕಂಪೇರ್ ಮಾಡಿದಾಗ 4s has got less energy compared to 3d. It depends on the orientation and shape of orbitals also. There will be different angles, based on that even it will be considered there will be certain small variation with respect to their energy. ಹಾಗಾದ್ರೆ 3s 1s ಆದ್ಮೇಲೆ 2s ಬರುತ್ತೆ, 2p ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ 2p ಆದ್ಮೇಲೆ 3s ಬರುತ್ತೆ, 3p ಬರುತ್ತೆ. ಬಟ್ 3p ಆದ್ಮೇಲೆ 3d ಬರ್ಕೋಬಾರ್ದು. ಸೊ 3p ಆದ್ಮೇಲೆ ಯಾವ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಫಿಲ್ ಆಗುತ್ತೆ, 3p ಆದ್ಮೇಲೆ 4s ಅಲ್ಲಿ ಫಿಲ್ ಆಗುತ್ತೆ ಆಕ್ಚುಲಿ. ಸೊ 4s ಆದ್ಮೇಲೆ 3d, then 4p. Even after 4p it is not 4d. So because among 4d and 5s which has got more energy, 4d has got more energy, and before adding to the 4d it is added to 5s. That's why we can consider with the help of this chart, of Pope principle chart, we can easily remember what is that actual order of filling the electrons. Now let me represent that. So which is that order? 1s will be greater or lesser. You can mention 1s is lesser than 2s, 2s is lesser than 2p, 2p is lesser than 3s, 3s is lesser than 3p, 3p is lesser than 4s, 4s is lesser than 3d, 3d is lesser than 4p. Agar ee order kottaga it is in increasing order. So which has got least energy? The first 2 electrons will be added to s. Then next electrons will be added to 2s, then 2p, then 3s. Like that we are going to fill the number of electrons based on the atomic number. So p ಅಂದ್ರೆ 6 electrons ಬರಿಬೇಕಂತ ಏನಿಲ್ಲ. So number of electrons based on the atomic number ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ we will write according to that number. You are going to learn later. So let me explain still more rules that to be followed before going to write electronic configuration for different atoms. Now I think it is very much clear for you people. So how to write this principal chart, and you can easily remember this chart. With the help of this chart, we can easily write the electronic configuration for any given atomic number. Got it?